Alright, so this is the quick check of your understanding about differentiability. So we will walk through two examples to check your understanding. The first one is called a step function. So this function is defined piecewisely. If x greater than 1, then f of x equals 1. If x is less than or equal to 1, then f of x equals 0. Okay, so we have the algebraic definition here and the graphical illustration. All right, so now let's talk about its differentiability. When you are referring to differentiability, you need to take a look at a certain point, f prime of x, the derivative of f at point x, or f prime of a, the derivative of f at point A. Okay? Alright, so to avoid confusion, let's take a look at f prime of a when a is greater than 1. So for a that is greater than 1, and the function f is equal to 1, it is a constant, so its derivative is always 0. Okay? Similarly, you can get the same result by observing this figure. So the derivative of a function is the slope of its graph, right? So when a is greater than 1, then we are looking at this portion of the graph. And this is a horizontal line. Its slope is 0. So the result is consistent with what we obtained by the definition. Another case is a is less than 1. So the function f of x is equal to 0. So the derivative of constant is equal to 0. So f prime a b. So f prime of a will be 0. Let's take a look at this graph. Okay, a is less than 1. It is still a horizontal line. Its slope is equal to 0. So that's why we get f prime a 0. Now, how about when a equals 0? Now, you might argue that the right derivative is 0, the left derivative is 0, so the derivative of f at 1, f prime 1 equals 0. Unfortunately, this is incorrect. So notice that when you are trying to figure out the differentiability of a function at a certain point, in addition to checking the right derivative and the left derivative, you also must make sure that the function is continuous at that point. Apparently, this function is discontinuous at point 1, so its derivative does not exist. Okay, so f prime of 1 does not exist because f is not continuous at 1. All right, so in addition to the right derivative and the left derivative, you also need to check the continuity of the function. Okay, so now I want to mention that after the differentiability, after taking the derivative of the function, the domain can change. For instance, in this example, the domain of f of x is the whole real axis, right? So domain of f of x is the real set. However, the domain of a prime of x is the real set except for the point of 1, okay? So as you can see, after the derivative, the domain becomes smaller by excluding the point 1, all right? So it's quite normal. After the derivative, your domain can change. But sometimes it won't, sometimes it does. Depends on the function you're working with. All right. So let me give you another example. Now, the function is sine x. Okay. We know that the value of x will oscillate between 1 and 0. Sorry, 1 and negative 1. So this is the graph of this function. And this function is differentiable at any point. So for a real number a, the a prime a will be cosine a, right? Because the derivative of sine of x equals cosine x. So this function is differentiable over the whole real set. How about its domain? So first, let's check the domain of x. Domain of sine x, which is the real set. The domain of a prime of x is equal to the domain of cosine x, which is also equal to the real set. So as you can see in this example, after the derivative, the domain remains the same, okay? There is no change with respect to the domain. But in the previous one, the domain changes after the derivative, okay? All right. So let me see a third example. How about you are given a polynomial f of x equal 3 times x2 plus 2x plus 1. All right. So for this function, it looks like this one. This is called a parabola. All right. And for this parabola, the derivative f prime of x is equal to 6 times x plus 2. Because we have some rule for polynomials, actually power function. So we have a times x to the power n, then its derivative will be a times n times x to the power n minus 1. Okay? So we use this formula to get the derivative of this polynomial. So I have 3 times 2, which is equal to 6, and the power 2 is minus by 1. So 3 times 2, you get a 6. And the minus 1, the power minus 1, get 1 here. Okay? And here this is 1, so 2 times 1 gets 2. And then the 1 minus 1 equal to 0. So x to the power 0, which is equal to 1. And for a constant, its derivative is equal to 0. Okay? Okay, now, as you can see, the domain of your original function, or domain of 3x squared plus 2x plus 1, is the whole real set. And its derivative is also the whole real set. So this is another example for which the domain does not change after the differentiation. Okay? In fact, polynomial or sinusoidal wave are continuously differentiable. So you can take as many derivatives as you want. Okay, they are continually differentiable. All right. So how about we work another example? So you probably will encounter this this function again and again. It's quite important. And x is a real number, e to the power x. And for such a function, its derivative in itself, so a prime of x equals e to the power x. Okay? So they have exactly the same domain. Which is the real set, okay? And also, its graph looks like this one. So here I have 1 e to the power 0 equal to 1, okay? So f of x equals e to the power x. Okay, so I hope these 4 examples can give you a better understanding of differentiability. So a function may or may not be differentiable at a certain point. You have to check. Also pay attention to the continuity at a certain point. If right derivative equals left derivative, you still have to check the continuity at that point. If the function is not continuous at that point, then the derivative does not exist. So I'm talking about this particular example, the step function, okay? This function is not differentiable at point 1. And sometimes the domain can change after the differentiation, like this one. And sometimes it doesn't. So all depends on the function you are working on.